example number 6. So example number 6 is quite medyo puti siya because that is an inclined surface and then it jumps off from B to C. If you notice, we have an R range here. So what do we do with this one? So with inclined surface, what we usually do, just like in our previous example, somehow we flip or we solve the dynamic equilibrium on the inclined surface. No, we adjust. So what do you have here? We have a 40-pound suitcase. We take note of the units. We have a 40 pounds. This is in imperial or English units. Just a brief review on your physics. The unit of the weight in imperial or English units is pounds. The unit of the mass in imperial or English units is in slugs. So mass is just equal to the pounds divided by the gravitational acceleration, 32.2 foot per feet per second squared. Just gonna write down it here. The gravitational acceleration is 32.2 feet per second squared. So that is the slugs or M. So you have a 40 pounds. So this is the weight of the suitcase. 40 pounds. The mass of the suitcase then is 40 over 32.2. This is in slugs. Slides from rest. Okay, slides from rest. So take note that we have 3 points, point A to B and from point B to C. Slides from rest. So our initial velocity is equal to 0 when time is equal to 0. And down this smooth ramp. Take note of the smooth ramp. When we say smooth, therefore there is no friction. Determine the point where it strikes the ground at C. So you're asked to find this R. Strike the ground at C, we will determine the point or the range or the distance R. How long does it take to go from A to C? Okay, so we're asked to find the R. And then we are asked to find the total time traveled from A to C. So in this type of problem, we have an inclined surface and then uh, we don't have the surface on this one. It is somehow being thrown from B to C. Therefore, the object at starting from point B, because this is somehow being thrown from point B to C, it acts like a projectile. So we have two times here to be solved. We have the time from A to B and the time from B to C. Okay, so this is the given items in this problem, and then the items that we're being asked. So let's proceed with our solution. Okay, from A to B, our acceleration is towards this direction. So in this type of problem, we will use this axis. Again, let's say this is our x prime, and then here we have our y prime. So we have here the x prime, and then we have the y prime. We have the weight here, which is equal to 40 pounds. That is 30 degrees. Since, yes, there is no friction. Yes, there is no friction. So what are we gonna do with this one? We were asked to find the time. What do we need to apply? We can sum forces along x prime is equal to the mass times acceleration along the x prime here. So let's say ang kato paingon dito panaog that is positive. So what do we have? We can get the weight, the x prime component of the weight, that is 40 pounds sine 30 is equal to, how about the mass? The mass is 40 over 32.2 times the acceleration along the x prime. So there is a 40 on the left and on the right side. They just cancel one another. Then our acceleration is just equal to 32.2 sine 30, or simply 16.1 foot per second squared. Next, is the acceleration constant or increasing? Obviously, the acceleration here is constant. So what does that imply? What does this imply when I say that the acceleration is constant? Then we can use the kinematic equation. We have the acceleration. What do we need? So actually, if magpa-atras na, no, if we try to solve it backwards to get r using the kinematic equation, we have the r is equal to the initial position or the position of the particle at B plus the velocity, horizontal velocity at B, times the time from B to C. So we need to get the time VBX. How are we gonna get the time? Sorry, the velocity at VBX? We need to get the velocity from point A to point B along the incline. So this is the incline. So we can solve this one. Or final velocity, or which is the velocity at B. So the velocity at B, that is on that direction. And then that direction of the, or that component of our velocity at B is just the VBX. And then the downward component is just the VBY. So here we get this one, incline velocity at B, that is equal to the square of the final velocity, or the velocity at B, is equal to the square of the initial velocity, or the velocity at A, plus what formula we have, the 2 times the acceleration times the displacement, that is SB minus SC. I forgot now that we have SA is equal to 0, displacement at B is equal to 20 feet. So the square of the final velocity, or velocity at B, is equal to square of the initial, that is 0, plus 2 times 16.1 times 20 minus 0. Then we can have our velocity at B, that is equal to 25.377,155 feet per seconds. We already have our final velocity. Can we get the R, or the range? So we can, let's not get yet the R or the range first. Let's get first the time that has elapsed or traveled of the suitcase from point A to point B, because we're asked to find the total time traveled from A to C. No? So let's take the opportunity to get the time from A to B. So we're gonna solve this one, of course, by using the kinematic equation. The final velocity is equal to the initial velocity. So this is, take note that this is from point A to point B. Relax lang. Well, mabuta ta. At point B to point C plus 18. So we have here 25.377 is equal to velocity at A is equal to 0 plus 16.1, the acceleration, that's the time. Then we have our time from A to B is equal to 1.576 seconds. Okay, we're already halfway. Next, now we are going to consider point B to point C. So if you're going to use the x or the range equation, r is equal to xb plus the velocity of b along x times the times time traveled from B to C, we have to unknown. We don't know the time from B to C. We don't know also the range. But we can use the displacement formula along Y. So that is the final height at C is equal to the initial height or at B plus the initial velocity or the velocity along Y of B, the velocity B times the time from B to C plus 1/2 times the acceleration dBc squared, or the time from B to C squared. So from this one, no, this is already our origin. Let's say our origin is this point at point B, and then we can consider that everything that goes downwards is a motion at this point is already downward is positive. So from point B to downward, that is 4, because the final position from point B to point C, that is 4 feet, is equal to 0. Plus the y component of our velocity at v, 25.377 sine 30 times the time from B to C plus 1/2. Now, what acceleration are we gonna use from point B to point C? So as I said from the beginning of this problem, that from point B to point C, the object is already acting like a free fall or in free flight. So we are going to use the acceleration in our projectile motion. That is the acceleration due to gravity, which is equal to 32.2 feet per second squared times the square of the time from B to C. Now we have here a quadratic equation, and by quadratic formula, you can obtain two times from B to C. One is negative, one is positive. Of course, we don't have a negative time, then you're going to use the positive one. And then we can solve that the total time traveled from B to C is 0.2413 seconds. So from that one, we have the R is equal to the initial position along X plus the initial velocity along X times the time BC. So we just substitute the values. This is a 0. This is 0.2413. Our VBX is just the cosine 30 degrees of this one. Then finally, we will have our R. The range is 5.30 feet. And our total time traveled. That is just the total time from A to B plus total time from B to C, or equal to 1.8175 seconds. So medyo taas yun, no? Here we combine the projectile and then the kinetics of a particle. So first we have an inclined surface. So we adjust the solving of that of our kinetics of a particle in the inclined surface. When we have an inclined surface, then ato sa siyang incline, we have the inclined axis. We have the x prime and the y prime. And then after that one, we have the FBD I showed here, and then we sum forces along the inclined axis, that is x prime is equal to the mass times acceleration x prime. And then we got our acceleration. And since acceleration is constant, we can apply the constant kinematic equation. We tried to get the velocity at B because we can use the velocity at B in solving the range R, and also the uh, displacement along y-axis. So when we were able to solve the velocity at B, we try to get the time from A to B using the constant kinematic equation again. So after that one, we proceed from point B to C. Again, from point B to C, the suitcase is already acting like a projectile. Actually, it's not really like acting, but acting as a projectile. And we can apply also the projectile equations from that one. So we have here the displacement along y, and then we got our time. After getting our time from B to C, we solve the range. And after getting the range, we got our total time because we got our time from A to B and the total time travel of the suitcase from B to C. And that is equal to the time total time travel is 1.8175 seconds. And the range or the suitcase landed at point C, that is 5.30 feet from point B. So medyo taas siya, but again, we try to simplify things. In the incline one, we don't use the x and y actual, but we try to use the incline axis. Okay, that's all for the problem number